Hi, my name's Doug, and we're coming to you tonight from Emerald Hills on the outskirts of Louisville, Kentucky. We call this channel the Emerald Hills Skies, and tonight we're introducing the Herschel 400 list of deep space objects. This Herschel 400 list, it actually originates with an interesting story. You might not understand, might not have ever come across this before, but it actually originates from an astronomy club down in Florida. And that astronomy club down in Florida was actually from St. Augustine. And the ancient, what was it called? The Ancient Club Astronomy, Ancient Skies Astronomy Club, something like that. Let me see if I can get that exactly right. Ancient City Astronomy Club. They created this list in response to a letter that was published first in April 1976 in Sky and Telescope magazine, page 235. And in that letter from James Mullaney from Pittsburgh, Pennsylvania, he wrote that really amateurs should set up an informal Herschel club, and they should try to observe the brightest of the more than 2,500 objects that William Herschel discovered and cataloged during his life back in, what was he born in? 1738. He did a lot of his observing in the early 1800s, but born in 1738. He was born in Hanover, Germany, and he began his career as a musician and a composer. And in 1757, he moved to England. And boy, after 10 years of trying to get by, he finally settled down in Bath. He was making a pretty comfortable living there as an organist and a teacher and also a concert director. But in 1772, his beloved sister, Caroline, she was born in 1750, she joined him there. And while she was there, she was taking care of his house and she was a vocalist. But right then, William Herschel started building telescopes. And over the next year, his love for telescopes actually eclipsed his love for music. I forget how many telescopes he made during his life. I think it was over 40 telescopes. Finally, he had a telescope that was like, oh my goodness, it was like 20 feet long. Let's see if I can find this picture for you. I'll hold it up here. This telescope was so big, it had an 18-inch mirror in it. Now, the mirrors back then weren't quite as good as the mirrors that we have in telescopes now. In fact, I read one study that 18-inch mirror back then probably is about equal to a 10.8-inch mirror today with the finishes that we have. The mirrors back then were made of something called speculum, wasn't very polished, and it also oxidized very quickly, like after just a few months in the telescope. So he was like peering through a glass darkly, as the Apostle Paul said. So really, to be honest, his 18-point-something-inch telescope, 20 feet long, was roughly equal to our RASA telescope. Now, I took this picture of our RASA just a few minutes ago in our observatory. And this RASA telescope is the kind of thing that's maybe 10 inches, 11 inches actually, 11 inches wide, and it would be roughly equal to the 18-inch scope that William Herschel had. Now that RASA out there in the observatory, I'll see if I can find a picture here of the observatory itself. This is a daytime picture of the Pier-Tech roll-off roof observatory that we have. It's 10 by 10 feet, and it rolls off, and then the telescope actually, I guess it adjusts, the height adjusts up so that the telescope itself sort of ascends above the height of the walls in the observatory, as you can see there. So it's a pretty fun scope. We're using this outrigger on it. We call it an outrigger, but it's really just an equipment plate with a little 178 camera, and it shows views of the sky. Let me see if I can get the picture of the sky there for you, because right now you're not seeing much of a sky. There we go. That picture of the sky is with an ASI 178. You can see a couple of airplanes kind of photobombing in. And that's that little red camera you see on the front of the equipment plate. And then there's a power box and a USB hub by Pegasus Astro. Down at the base of the adjustable height pier, we have this, what we call a rig rack. It's got all the electrical distribution for 110 and then 12 volt. And it lets us kind of spy what our voltage and amperage is running. And then it also has the box that sends the images in from the observatory over fiber optic cable. Rats, I meant to show you a picture of that cable. I have to do that maybe later, but it comes in to where I'm sitting, which is about 200 feet away on the inside in this nice air-conditioned office, you know, and I don't have the bugs. So Herschel, during his career, I was telling you about Herschel. Let me show you a picture of him. Herschel was, he managed to find about 2,500 deep space objects that had never been discovered before. When he started, the only catalog that existed was the Messier list. And you've been around this channel before, perhaps, and you've seen that we have done Messier marathons in the spring. We're doing little by little what we call a sky portrait at a time of each of the Messier objects. So we've covered the Messier list, but this Herschel list, it is of the 2,500 objects, 2,500 and something objects that Herschel discovered. And so this club down in Florida, in St. Augustine, they saw this letter from this guy, James Mullaney, that said, it's a large list. What if you could carve it down and just take the brightest objects? And I think he proposed 615, but the ACAC members, they decided that they would come up with a list of 400, and they would pick objects that would challenge observers with larger telescopes, and they also decided that they would challenge observers who were in light polluted skies. And that's the way our sky is tonight. We have something like Bortle 6 skies that you see there on the edge. It's a live view through that 178 camera. You know, they wanted to try to find a way to challenge observers that had those light polluted skies. And so they came up with 400 objects. It's not necessarily the brightest and best of Herschel's list. Instead, it's a list designed to hone or to test the observing skills of amateur astronomers, especially in the northern hemisphere, and that's where we are. So this thing became popular to the point that the Astronomical League, AL, the Astronomical League, which is composed of like 240 different amateur astronomical societies across the USA, they began to award certificates to members of these societies that would be able to complete looking at all objects on the Herschel 400 list. And this certificate kind of awarded them a sort of a level of advanced observer. And one of the best books on this Herschel 400 list is this book by Stephen James O'Meara that I'm showing you tonight, the Herschel 400 Observing Guide. And this is a great book because it breaks the list down. It gives a little introduction at the beginning, and then it breaks the list down by charts, one object at a time. So it lets you find the objects with these maps, and then it shows you pictures of the night sky and pictures of the individual objects. So what I think we're going to do is use a combination of things. We also have with us, we have the, I'll see if I can cue it up here. This is a Planetarium software, and it's called Starry Night Pro Plus. And on the side here, over here at the side, I know it's fine print, but on the side, we can call up a working list of a particular catalog. And we've got the working list of the Herschel 400, and we can sort it by altitude. And then within each object, we can go look at it. And then once we've observed it, we can move it over here to this list, which we're calling H400 Observed. So this becomes a kind of a list of things that we'll check off as we go. And then what we'll do, we'll go to a browser panel, and we'll go to Starry Night Pro's livesky.com, it's called. And using this browser will let's see, will call up the observing list of the H400 working list and will remove the object that we've just observed. So again, going back, you can see there in this screen, here's the H400 working list and the H400 observed list. So the working list has 400 objects. The observed list right now has 0. And as we work our way through the H400, the Herschel 400 list, little by little, that list of observed objects will grow. And the list of objects that are yet to be observed will lessen. I'm looking here on my phone just to make sure that I can see the stream, and I can't yet. And I wonder why that is. Why am I not seeing the stream? Because our software tells us that we're streaming. Let's go over here to our actual, not receiving enough video to maintain. There might be buffering. Rats. I wonder why that is. Let's see, what would cause us not to be sending enough stream? That's no good. Well, I'm just gonna make a message here, and I'm gonna say, if you're listening, well, there I see Jeff Horn, you're on, and Frank, good to have you here as well. Stephen Kaiser, welcome from Scottsdale. Papa Tech, you're on from stormy Florida. It looks like you're there, so maybe it's streaming after all, in spite of that error. But why am I not seeing this on my phone? You see, I usually can call up the live stream, but I'm not seeing the live stream on my phone, which is kind of unhandy. Maybe I'm just going to take 1 second here and try to figure out, why are we not seeing this? So the phone is on, it's on Wi-Fi, and yet I'm going to try to go to the channel again and make sure. There it is. Okay, I knew that there was. I'm going to turn down this audio. Now I can a little bit more. All right, so I think we've got the layout. We've introduced the Herschel 400 list. So now I think we're ready to go to our first object. And I'm glad you guys are here because you can help kind of describe these as we go. This is my first time with most of these objects. So we've sorted by altitude. Let's do one more sort just to make sure. NGC 5033. We're going to open up an info pane on that. And that's NGC. Now, it doesn't tell in Starry Night Pro what number it is on the Herschel 400 list, but we're just going to have to deal with that. And what we'll do is we'll center on that object. So we'll kind of see where it is in the night sky. And we're using, again, Starry Night Pro Plus for our Planetarium software. And you can see it's almost up exactly at the zenith in the constellation Canis Venatici, however you pronounce that. Another thing we want to do is go here to View Telescope Control, and we're going to try to connect to the scope. And hopefully it will connect. Sometimes it seems like it takes it a little moment or two. Not sure why that is sometimes. To connect. Then what we do is once we've connected, we actually control the telescope from within Starry Night Pro. It is not wanting to connect here, so we'll just take a second. Try that again. You know, it is live TV, gang, so close this and open it again, and maybe when we open it again, it'll say it's connected. Wouldn't that be great if it said, oh, it's not. So I'm going to connect one more time, clicking. I'm just going to go up and check on our mount and make sure everything looks good here. Looks like the mount is connected. Oh my goodness, Starry Night just crashed. So that's, again, we're live TV, aren't we? So we're gonna open up Starry Night again, and this time we'll try connecting to it to the mount first in Starry Night Pro. We're gonna leave shaders on. Just this past week at the Starry Night Pro help site, a user there with the name Zhao or something like that said he was having trouble, and his version of Starry Night Pro was freezing when he tried to connect with it. And, I wrote him and said, oh, we've never had problems like that. So I spoke too soon, didn't I? Let's go back here, and we're going to try to look at our, let's call up our lists and open up the Herschel 400 working list. And there's our telescope control. And we're going to try to connect. And it's still not wanting to connect. What do you guys think? Jeff, do you ever have problems with your telescope rig? Frank, do you ever have problems up there in Schenectady? Stephen in Scottsdale, do you guys ever have problems? Pier-Tech in Story, Florida, do you ever have problems? Surely you don't. We often joke in electronically-assisted astronomy. And electronically-assisted astronomy is when you take a telescope like this, that's a live view through kind of a webcam that's out in the observatory. It's a live view of our RASA 11. No issues on the ASI for me, Jeff Horn says. We connect that telescope so that we can see it through the computer. And then we live stream what we're seeing. And I think sometimes it's just a little bit of much juggling act. Pier-Tech says it's the ASI Air software there, and it's very simplified. Well, I'm starting to think maybe the ASI Air is the way to go, because tonight we're not wanting to connect here. And we're so accustomed to connecting with Starry Night Pro that we don't have an alternate pointing system, actually. So right now we don't have well, while that's doing that, while we're getting that set up, I'll go down here to the title, and I'll say that this is going to be to read right. Oh, look at that. Yeah, that Starry Night Pro just crashed again. Try it again, and if not, we're gonna back up 5 yards and punt. And the way that we'll do that is we'll be able to we'll open up Astro Planner, which is an old program that I used to use. Haven't used it lately, but let's see. Just go back out here to observing lists and leave you guys on the title just for a second while this is all updating. Close Live Sky for a second. Looks like we're still streaming. Can you access the scope directly? Yes, we are accessing the scope directly through the iOptron commander, so that's working. I think I'm going to actually, boy, it'll be inconvenient if we don't get. Let's try this again. Telescope control, connect. Ah, good. Okay, now we're connected. Okay, well, that's the way live TV is sometimes, isn't it? Now we're going to go to our lists, and we're going to choose the Herschel working list and make that screen a little bit bigger. In electronically assisted astronomy, we've often said the joke question, what can possibly go wrong? And the purpose for asking that question is to kind of point out there's a lot that can go wrong. You can see our scope right now. We're pointed at the North Star. So this is this red rectangle right here in the middle. That's actually a rough approximation of the telescope's field of view. That's what the camera is viewing through this telescope that you saw a while ago, this RASA 11-inch, and the camera is an ASI 2600MC Pro. And right now it's pointed at this part of the nighttime sky. You can see the Big Dipper if you look closely there. So we're pointed up at the North Pole. So what we're going to do now is you see that our planetarium software is sorting through all of these Herschel 400 list objects. And it's looking at what is the altitude and giving us a sort capability for all these 400 objects. And then what we'll do, once it's gone through and sorted and found all the altitude, we'll sort that altitude by what is the highest right now, and we'll go to that object. So there you go. So now we're going to sort, and you can see we're looking at right now NGC 5273. So we're going to open up an info pane on that particular object. It's a galaxy. And then we'll center on that object. And now that we've connected the scope to it, we'll actually slew the scope to that object. And you can watch the scope right there as it moves. And right now it's going Pier west. And as it goes Pier west, you can see the weights are going up on the east part of the sky. That would be as the camera is looking at the scope from the rear of that polar view, the weights are now on the east side. The camera is looking almost directly up to the zenith, which is the basically directly overhead. And we'll now just enter our title, which is NGC 5273, a spiral galaxy. And then we'll come back up to the screen. And you can see where we're pointing. If we bring a lot more constellations up on the screen there, you can see we're in between Bootes and Coma Berenices, just right off the tip of Canis Venatici. And a good way to find this galaxy would be to find the Big Dipper. And we're all used to looking at the Big Dipper in the sky, huh? And then follow the line, the arc of the handle until you get just to the right of this kite-shaped constellation called Bootes. And almost at the zenith, you would be able to then find NGC 5273. So what we're going to do now is go over to our live view through the ASI MC2600, the ASI 2600MC Pro, and we'll put the name of the target in this sharp cap, which is what we're using here, NGC 5273. And we'll connect to the mount through sharp cap as well, and we'll do a plate solve. And what sharp cap now attempts to do is synchronize its view through the camera with what it expected to see in this part of the sky based on its software version of the database of all these star objects that it's looking at. And now it's going to try to synchronize those, and it's going to say, okay, based on my database of star plates, you know, like that's the old-fashioned word for photos, I should be seeing this plate view based on the target that you just sent me to, the coordinates to which you just sent me. But instead, I'm looking at something that's 1.02 degrees away. So what it's going to do now is it's going to synchronize the actual pointing of the mount with the pointing of right now with what it should have been pointed at. And so it's able to point us so that NGC 5273 would be right in the middle. And now that we've plate solved, what we're going to do is go up here under our sequencer, and we're going to actually start imaging this part of the nighttime sky using a different exposure. We're going to go with 20 seconds. We're going to try 20 seconds first and see how that does. And our gain, we're going to drop down to 100. We were using a 3-second 400 gain or 3-second 300 gain, I forget. And now we're at 20 seconds, 100 gain. And what this will enable us to do is take basically a time exposure of the nighttime sky. If you're new to this, then basically what we're going to look at is a time exposure. And then not only one time exposure, we're going to stack multiple time exposures on top of each other and average those together. And that will enable us, hopefully over the long haul, to average out some of the noise based on just light pollution and a lot of other artifacts in the nighttime sky. And we'll be able to hopefully attain a more, I guess, in-depth view of the nighttime sky. Now, just looking here at the first frame, 20 seconds, there's no galaxy visible there that I can see anyway. So what we're going to try to do is use this stacking approach, and that's really the heart. It's at the heart of electronically assisted astronomy. If you're new with us tonight, that's the heart of EAA, is doing this live stacking thing. So we're going to go over here at the bottom, and we're going to try to, first of all, do a bit of a white balance, we used to call it, in old-fashioned cameras. And when we white balance these different colors, we're going to now adjust the black level, so we basically set a new black. And we're going to say, let's assume that you don't have to worry about any of those other frequencies. What would the new black look like? And we're just going to have maybe just a speck of the light pollution, just to keep only a speck of it, just to keep a little bit of the sky glow. And then we're going to start bringing up the mids. And we're going to go there. You can start to see something very fuzzy in the middle of this picture. And we're going to go to a full 100% zoom, because I can already tell this is a very small object. And right here in the middle of this frame, look at this fuzzy object that's there. It's just kind of just like a faint fuzzy there in the middle. Now, while that's live stacking, we're going to also look at the description of NGC 5273. And it's so faint and so nondescript that Starry Night Pro doesn't have any information on this object at all. And we've never observed this object before here at Emerald Hill Sky. So we're going to open up our first entry here, and we're going to associate an observing list with it. And the observing list we're going to use is, let's use H400 all for the observing list, because that'll always be consistent, you know. For our observing session, guess what it's already done? It's picked up the session that I had pre-configured, and I did this last night, right before going to bed. I set tonight's dates and times and said we would do this, the Herschel 400 observing session, part 1. And I'm going to just write here in our notes, this object was so faint, and oftentimes on the first entry that we create, Starry Night Pro actually does this little, the object was so faint that we couldn't see a thing in the frame after 20 seconds. On a few additional frames, 2 minutes, we began seeing a faint fuzzy. Now, why is this object so nondescript? Well, you'll recall that club in St. Augustine, ancient, what was it called? Something or other club. They intentionally chose objects that were more difficult, those rascals. And I'm going to pick the telescope equipment that we're using is the 2600 and add that to the observation. So now let's move this out of the way and let's go back to our live stacking. I'm looking forward to seeing if you guys, Papa Tech and Jeff Horn and Frank Rossetti, if you've ever observed this object. Doesn't look like it has any kind of nickname. Let's do another color balance here. And we're going to bring up the black level a little bit to this new level. Now, it is a very clear night, and by the way, although the moon is still at 50 or 60%, the moon has not risen yet. So we can't blame any of this on the moon. This is actual observing. Now, here's what's wild. William Herschel was so good, he observed this object live in his eyepiece. with, although it was an 18.7-inch wide, aperture, like I said, the study that I saw said it was roughly equivalent to the 11-inch scope that we're using tonight. And so I cannot blame anything tonight, be it moonlight or anything. The only thing I have is we have some light pollution here at Emerald Hill Skies, about a Bortle 6 sky. But other than that, this is the real deal. Let's try making the sky a little bit darker. And that's letting us see the bright core. So for our first Herschel object, I think we're into a more advanced level. I searched YouTube. Look at that, could not align frame. So I wonder if that is the wind. I'm going to go ahead and save this exactly as seen. The wind is whipping up rather sharply tonight. Let's look at quite small and dim for my 72 ED. I have not observed that object, Jeff says. I'm going to look at the wind and see if I can get a reading on what's been the most recent gust. Right now, the wind is not that strong. But there are gusts out there. I would estimate that those gusts have been maybe up to 10 miles an hour. I'm just seeing if, well, it says 4 miles an hour. Well, that's not very strong, is it? And really, the observatory that we're using puts just the top part of the scope. So I can't blame it on the skies. But wow, this has definitely stopped aligning, hasn't it? So let's stop our live stack, and let's just restart it. Oh, look at that. That looks like a tracking problem, doesn't it? Let's go here. Tracking is not enabled. That would make a difference, wouldn't it? If tracking were to be knocked off. Isn't that strange? It won't let me enable tracking. So what we're going to do, again, this is live TV, folks. We're going to right now go back to the zero position. Go to zero position. You know what I bet happened? I bet this object, which was so close to the zenith, I bet it got so close to zenith that the mount actually bumped back into its meridian, the highest it could observe, and couldn't go past the meridian. And I must not have this configured correctly to automatically do a meridian flip. But even if it had done a meridian flip, that would have been very unfortunate, wouldn't it? Because we were in the middle of live stacking. So now let's try to enable tracking again. Okay, now tracking is sticking. So let's close that. Well, we're just learning all kinds of things here. Now let's slew back to this object again. So we're going to go back to NGC 5273 and slew to it again. And now it should be past the meridian. So let's look at this in our Planetarium software to be sure. There comes the mount. You can see in the Planetarium software the mount. This is little crosshairs. That's indicating the position of the mount. Now I'm going to back off a little bit and try to see where we are. Yes, now we're on the west side of the meridian, see? Okay, so that was quite of an adventure, wasn't it? So let's go back to start that sequence again, and this time hope that since we're past. So let's talk for a second about Equatorial Maps, since we have a moment here. You see how now the weights are on the west side of the mount, and we call this Pier East because the telescope is on the east side, and now it's gone past straight up, and now it's able to swing with the sky and not get hung up on the zenith point. The way the scope was before, it was actually, if you can just think about, imagine you're the telescope looking up near the zenith, and finally you get so close to the zenith, I have my chair set so it doesn't recline, and I get back here and I can't go back any farther, and I bump and I bump and I bump. So what we had to do is we had to scoot the telescope around this way, so now it's able to look up and follow the nighttime sky. So that's what happened. So now you can see with our telescope, we can now swing with the nighttime sky. So let's go back to our target again, and we're going to go back out to, since we did a meridian flip, we're going to actually, before we let's turn live stack off. Let's do one other thing before we do a live stack. Let's do plate solve first, because this is our first object in the nighttime sky after we moved from polar alignment. And the way these telescopes work is after you polar align, you need to usually star align. Well, our mount is so accurate, we don't even star align. We just, after we polar align, that is aiming the axis that goes up through the scope. If you think about, I'll show you a picture of the telescope. See the way the telescope is pointing at the North Star, and we align it perfectly here in this picture point. We align it perfectly pointing at the North Star so that then we can come back here, and sure enough, it was off 1.04 degrees. So now that we've plate solved and aligned it, we're going to be closer on our next target, and we won't have to plate solve as many times. I usually plate solve maybe the first 3 or 4 targets. And after plate solving the first 3 or 4 targets, then we don't have to plate solve anymore. So now we're collecting the first image again of this target. And again, these are 20-second images, so it doesn't show up at first. And then when it finishes the 20 seconds, all of a sudden, bam, it shows up. And you'll see it just kind of, there it went, bam. And the original color balance is usually off a bit. So we have to reset the color and balance again. And you can see that real faint fuzzy in the middle. So let's zoom into 100% again. And again, this object is quite small and quite dim. But now that we're actually going to live stack, this is a collection of 40 seconds frames. So I'm going to go over here in our observation, and I'm going to put down here that, well, I'm going to hope to put down here that, wow, it's just not wanting to let me, we had to reset the scope because this object was at the zenith and finally past the zenith. Now, I'm curious, you guys that are watching, some of you are more experienced than I am for sure. What do you do when you're live stacking and your scope is approaching the zenith? Do you just kind of try to watch it and not choose an object this close to the zenith? Is that kind of what you do? Because I just picked the highest object, and it happened that it was east of the zenith. And when it swung west of the meridian, that messed up our live stacking. So I'm curious what you guys do in order to prevent that. Notice that in our frame, this object is still pretty faint and fuzzy. That's zooming in 225%. So what I'm going to do here is go out to the web. I'm going to open up a browser and say NGC 5273 and see if there's a Wikipedia page on this. There is, NGC 5273, but not much about it at all. But look, there's the object. I don't know if you can see that. That's the object that an astrophotographer collected. And you can see there's not very much spiral structure visible there, is there? Let's zoom in as much as we can. So this is the astrophotographer's view. And now let's go to the live view. This is our live view. And I would say that we're just kind of seeing a smaller version of that same thing, aren't we? Seeing a smaller version. I'm kind of A-Bing. Do you feel like you're at the eye doctor? This is A, this is B. A, B. Now, which is clearer? A or B? Well, the astrophotographer version is definitely clearer. It's the version that probably somebody spent, 6 hours collecting. It was the Sloan Digital Sky Survey. And I'm sure we could look up that telescope, the Sloan Digital Sky Survey. I bet you they spent, 20 minutes on this object at least. Let's see if there are any more details here. They don't really tell, I don't think, how long this exposure was. It was with a 14-inch observatory grade telescope, but it could have been 20 minutes for all we know. Anyway, that's NGC 5273. Now, while it's always look to see how long till it crosses the meridian, Pier-Tech says, ASI Air will do the auto flip, but not necessarily when doing live stack. I see. Pier-Tech, I've learned something tonight. So that's what this is all about, isn't it? Is learning as we go. I'm going to go to the back of the Stephen James O'Meara book and look up NGC 5273. This is Herschel, I guess it's 198. Is that what that means? On 193. So Stephen James O'Meara covers this on page 193 in his book. And he says, it's a very small, faint lenticular galaxy near 5th magnitude. A dark sky is required to see it. It says it's ill-defined and small, even in larger instruments. Ill-defined and small, even in larger instruments, he says. I'm afraid we're falling prey to... He says, be patient. Work with moderate magnification and use averted vision. Averted vision, is when you glance off of an object and you're not looking directly at it. So Stephen James O'Meara includes this picture of NGC 5273. Again, it looks exactly like what we're seeing in this picture, except our picture, of course, a little bit smaller. Now, how does he label these? He calls it H, and then there's a Roman numeral 1-98. Does somebody know more about the Herschel list and can tell us how does this numeration work? Did Herschel... Let's learn about this. He put a 1 in front of it, a Roman numeral 1 in front of it. I kind of remember a little bit about this, and somehow this told you what kind of object it was. Remember? Let's skip ahead a little bit. Okay, here we go. A Roman numeral 1 meant bright nebulae. Well, that's a joke. He thought this was a nebula. That's how bad his image of it was. He didn't even realize it was. Well, you know what? When he was observing, galaxies hadn't been defined yet. He thought this was still a cloud. So he thought it was just a fuzzy glow. So I don't know how much this number system, 98 is what he called it. I wonder, is that 98 of his nebula? And so, is there more than 198? I bet there is. Yeah, I bet he starts over his list. So that's not going to help us much. But let's try it. H, Roman numeral 1-98. So we're going to call this H Roman numeral 1-98. This is HI98 on the Herschel 400 list. Okay, there's our observation. And you know what? It still looks like a faint patch. So that's 7 minutes. We're going to call this the other galaxy shows on your live stack. Oh, you're right. There's another galaxy right there. Let's go back over to the Planetarium software and let's zoom in to the Planetarium software, and that is NGC 5276. So I don't know if that's a Herschel object or not. NGC 5276. So we're going to look here under NGC. Oh my goodness, he's got them listed in several different formats here. He's got them listed by constellation, and then he's got them listed by Herschel objects in the order of H1, H2, and H so on. Then he's got them listed by NGC objects. So the other object was NGC 5276. That did not make the cut. So Herschel did not define NGC 5276. We'll go on, and in our show info, in our observation, we'll say Pier-Tech picked out another galaxy, NGC 5276, not on the Herschel list, visible very near this galaxy. Those are sharp eyes, Pier-Tech, and I think that also shows something else. You see how Pier-Tech was observing through this live stream, because why is that? It's because Pier-Tech is seeing exactly what I'm seeing and exactly what you're seeing. We're all observing this at the same time, and that's why he was able to see this other galaxy, NGC 5276, whatever that was. Now I'm going to have to go back and call up our observation again because I've forgotten the exact name. We're looking at NGC 5273, the object that, 5276. The object that Pier-Tech saw was NGC 5276. And he saw it real time by looking through the live stream at exactly what our camera was seeing. So that's pretty cool, Pier-Tech. Well done. All right, let's save this picture after it just turned to 10 minutes. All right, there's our first object on the Herschel 400 list. So now what we do, we go back over here in the Planetarium software, and we add this to H400 observed. Now, so far, I've not been taught or trained how to remove this from the list that we're on. There is a command that looks like it should remove. It says remove NGC 5273 from H400 working. And you can click on that, but it never does. It never removes it. So I think that command is either an illusion in the twilight zone or else it's got a glitch in it, but it doesn't work. So what I do, because I'm doing this as a workaround, I go back to our browser and I open up Live Sky, which is a really cool interface that Simulation Curriculum, the makers of Starry Night Pro, gives us to look at the different databases that are inside of Starry Night Pro. And the cool thing is, it's looking at them fairly real time. I say fairly because there's a little delay, but not much. And I'm going to go to H400 working. I'm going to edit, and I'm going to search for 5273. And I'm going to remove it from the working list. Delete. And then save that. And I've noticed over time, we might as well go back out to the observing list again because sometimes it gets weird, Okay, so now we've removed it from the working. We first put it in the observed, and we're ready to stop our live stacking. So we're going to go sequencer and go to next target for our sequence. Now, some of you have asked, just lost power onto my phone now. Dedication. Papa Tech he's got such a bad storm that the power just went out of his house. So he's using his phone on battery. For all we know, he's got a hurricane coming, and this could be the last time we hear from Papa Tech for a while. And he's using up his phone battery to watch our live stream. Papa Tech, that is dedication. So for you guys that are observing, I'm just fascinated to see how much you've done in the Herschel 400 list. Because as you can tell, I have not done much. This is like first for me. I'm going to make this list a little bit wider so we can see those objects out of the side. And now we're going to go to the next object, which is NGC. Well, let's do a sort again. NGC 5557. And let's center on it first. You see, you guys are teaching me. If it's east of the meridian, we might want to wait until it passes the meridian. And it is east of the meridian. So let's go to, we already did 5273. So I'm going to uncheck 5557. Let's see where 5466 is. 5466 has just passed the meridian, and it's on the west side now. How do I know that? Because if I back out, way out, I can see that we're looking at the southern sky here. And how do I know this is the southern sky? Well, because look, I'm seeing Virgo instead of the Big Dipper down there. So we're looking at the southern sky. That means that objects to the right of the meridian are on the west. So let's do this next object, which is 5466. Looks like it's an open cluster, doesn't it? Let's see. Let's check that, and let's check. Let's open up the info pane. A globular cluster it is. It's a very loose globular cluster. And let's go to slew to that with our scope. So there goes the scope. Didn't have to move very much. It just backed up a little bit. If you saw it there, inch back, closer to the meridian. And we're centered. Let's put this in our title, NGC 5466. NGC 5466, a globular cluster. And it is in the constellation Boötes. So I'll just add that to the title. In Boötes. Is that how you say that? Boötes? How do you guys say that? Let's go back to our screen. And this is, we've never before observed this. Let's do another plate solve because this is just, remember, our second object since we began slewing around the sky, and it helps to do the first 3 or 4 again. This one's very close to the last one, so it might not have much of a correction, huh? But what happens is the mount is like a computer in and of itself, and it stocks up in its memory these plate solving corrections that we give it. And just looking, there aren't a lot of, oh, it's because we're zoomed into 160%. It was only off 4/100ths of a degree, but it stores away these corrections, and it enables it to plural boot. Boots? So you just say boots, Papa Tech. Well, that's pretty cool. The fact that it has the ES on the end, I guess, was confusing me. So now we're going to change this title in sharp cap. You have to change it in both places. And it's NGC. Now we have to change it here because this affects the name it's going to give to the picture we take at the end. So we're plate solved. We're ready to change our sequencer now to the actual imaging run, which you'll recall is the longer exposure, 20 seconds. Maybe some of these objects we might have to go to 30 seconds. What do you think? Because they're so faint. Maybe we're going to have to adapt to this new, world of the Herschel 400. It says NGC 5466 is a globular cluster in Boots, Pier-Tech says. It's 5400. Just back these mids off a little bit. Oh, that's a good view. It's 55,000 light years away from the sun. It's large and faint and only resolves into stars with larger telescopes. Woohoo! I'm just so thrilled. 11 inches is apparently a larger telescope because look, we're definitely seeing this resolve into stars. Let's zoom in a little bit. Do what? I don't know if you guys were here the night that Frank taught me to hold the control key down and zoom with the mouse wheel. We have a mouse that has a wheel now. Early on, we were just using the trackpad, but now we have a mouse that has a wheel, so we can zoom with it. So there you go. That's NGC 5466. After just 80 seconds, that globular cluster is already pretty impressive. By the way, thanks for joining us on the live stream tonight. If you have not yet typed in a message of where you're observing from with us, please do that. I say where you're observing from because you're actually observing the same thing I am. And if you didn't believe that, you just missed a great proof of it. We have one of our observers tonight observing from Florida through this camera telescope setup that we have. And he saw a galaxy by observing, and it was indeed there, although it was incredibly faint. It's not on the Herschel 400. He saw it, and so he's observing from Florida in the middle of a thunderstorm that took out his power, by the way. So Pier-Tech says, not sure if it's actually pronounced Boots. I just try to keep it simple. Like me, Pier-Tech says. Well, while that's stacking, just one or two more frames, let's go to the web. And let's say how to pronounce constellation Bootes. And we're going to go to Astronomy Pronunciation Guide at space.com. And it says some astronomical names can be a little difficult to pronounce. For example, the constellation this is pronounced Bootes, not Boots. Pier-Tech, you're about to lead us astray, you rascal. It's pronounced Bootes, so I didn't have it right. Bootes should have been the proper pronunciation, according to space.com. And they own a pretty good domain, so let's give them the benefit of the doubt. Okay, so 3 minutes, we're going to call it a day here because we've got, I hope you can see a fairly good view of this object. Let's try to brighten it up just a little bit more. Oh yeah, look at all those colors. You're now seeing some blue stars in that globular cluster, which is interesting, isn't it? Because we don't always see blue stars. 55,000 light years. It takes about 1 billion. Whoa. NGC 5466 revolves around the hub of our galaxy every 1 billion years. That's pretty wild. It's only 9 arc minutes wide, so that would be what? 1/6 or so of a degree. So let's add a long entry here. And we'll say this glob showed up in our first 20-second frame. After 3 minutes, we could make out multiple star colors. One more thing let's do. Let's go to NGC 5466 in the Stephen James O'Meara book, NGC 5466. This is H, Roman numeral 69. Will I remember that? One of you guys remember that for me, won't you? Page 212. Oh, he'll have it written down. When we get to 212, he'll have it written down again. Okay, so here's the astro photo view that he shows of NGC 5466, or H, Roman numeral 69. It's a globular cluster in Boötes. Papa-Tech says, never going to be pronounced that way by me. Too difficult. Laugh out loud. That's fun. It's a beautiful globular cluster, Stephen James O'Meara says. He says, it looks like a tailless 9th magnitude comet. I love Stephen James O'Meara. Do you know, once our family went to Hawaii for multiple reasons, but we actually drove to the place where Stephen James O'Meara lives. Now, I didn't go up to his door and knock, but I just wanted to say I've been to his town and driven past his house. Don't call me Stephen James O'Meara, whatever you call somebody who follows a celebrity. But if you're watching this tonight, Stephen James O'Meara, I did stalk you. No, not really. He tells how to locate it. He says it's an 8-minute wide, round and uniform, comet-like glow, no central condensation. He's right. Look, there is no glob in this globular. With averted vision, the globular shape becomes irregular and somewhat frazzled along the edges. Well, our RASA is saying why. It's because these stars are irregular along the edges. He breaks into dim mottled patches with some irregularities. Larger scopes will begin to resolve some of its brighter members. Woohoo! Go Celestron, who invented the Roe-Ackermann-Schmidt astrograph, and the ZWO people who have the ASI2600, because you are resolving some of its members, a lot of its members. I think we could probably count 150 there tonight. It shines at a magnitude 13.8. Well, that's awesome. H, Roman numeral 6-9. Power running low, internet getting slow. Have a great night. Thank you for the observer time. Papa-Tech, thank you for being here. We enjoyed, especially because we saw that you were observing there. H, Roman numeral, oh, rats, I've forgotten that number already. Was it 6? Somebody help me out. Was it Roman numeral 6-9 on the Herschel list? You know, that's pretty confusing that you can't just number these like 1 through 400, isn't it? It's kind of a bummer. Herschel did it by Roman numerals. What was he thinking? We read the, how do you spell O'Meara? The O'Meara book, and it described it well, except through our RASA, we could see an estimated, I'm going to estimate this at 150 members. No central, what would you call that? Bulge or core in this glob. Well, that's just a lot of fun, isn't it? To think that William Herschel saw this with his bare eyes through his 20-inch telescope. And we're using EAA tonight. I'm going to save a copy of this at 8 minutes, saving it exactly as seen. Don't forget, if you're on the live stream, don't hesitate to tell us where you're observing from. This was NGC 5466, Herschel, Roman numeral 6-9. Okay, back here we're going to say, add this to the observed list. And then we're going to go over here because we know this works. Back to live sky, edit, and search for 5466 and remove and save. Now see, I gotta say, it would be handier if Starry Night Pro is able to fix this. I'm going to turn this in because I'm sure I've checked that before. Okay, so that's our second out of 400 objects. We are in for the long haul here, but hey, that's okay. It's advanced astronomy. By the way, if you go to YouTube and search for somebody who's going through and imaging the Herschel 400 list, I dare you to try to find it. I couldn't find a single example. So this is, as far as I could find, folks, now maybe I'm wrong, you tell me if I'm wrong, I found one guy who had taken astro photos of the Herschel 400 list, and he had made a video, but nobody that's done live EAA of the Herschel 400 list. So this is a first time, as far as I can tell, on YouTube anyway, first time it's being done. Now let's resort back in Starry Night Pro Plus, and let's see if NGC 5557 is past the meridian yet. So we're going to center on it. We're going to back away. And it is. Now, how did I know that? Well, because as I back away, I'm seeing constellations like Virgo here instead of northern constellations. So I know that we're looking at the south sky. And then this is the meridian, and we are on the right-hand side of the meridian if we're looking south. So now I know we're already west of the meridian. So we can go to this now. NGC 5557. So we're already centered on it. Now we're going to slew to it. And you'll see we don't have to move the telescope very much for us to see it. This is another elliptical galaxy, and it's in the constellation Boötes again. NGC 5557. So let's go down to our title. NGC 5557, an elliptical galaxy in Boötes. Now let's go back to SharpCap and let's go back out. Oh, we didn't stop our live stack. That's okay. I had already taken the picture, so we're okay. Let's go to next target just for a second. Let's don't plate solve because we didn't travel very far, and I don't think plate solving is going to accomplish that much for us. Let's change the title to 5557. And now let's start our imaging run. And it should still be fairly close to the center. While that's starting to image, we're going to go look it up in Stephen James O'Meara's book. NGC 5557. It's H199 on 212. 212. 212. Still fairly grainy, but you can see we're seeing an object here. 5557 is H199. This is right beside the galaxy the globular we just imaged. And so he's covering these so that you're going from object to object in his book. It's a very small and faint galaxy. And you have to use a dark sky and use averted vision, moderate magnification. Think fuzzy star. Yep. Is Stephen James O'Meara good at describing these or what? Look at this. That's exactly what it looks like. A fuzzy star. And look, he says it's very near third magnitude gamma Boötes. Now I'm assuming that's this. This is another star. Let's go back over to our Planetarium software for a second. And hello. Let's see the names of these stars. Well, let's look at this for a second. That doesn't look like it's gamma, whatever you called it. But there's that star. It's so nondescript it uses an USNO designation. So where is this third magnitude star he's talking about? Maybe this. Starry Night Pro would help us if it used the gamma, maybe this. Hipparchus 69879. Show info. Wow, it doesn't identify these as the gamma whatever. Let's see if he makes a chart here. 5557. There are those. So this must be it. The gamma star he talked about. No, I'm sorry. Yeah, that's it. That's the gamma star. But unfortunately, Starry Night Pro doesn't name stars by Greek letters, does it? It's kind of a bummer, isn't it? Kind of a bummer. Gamma Boötes. Now we could, if we wanted to, don't forget, we're on 5557. Let's go up here and say Gamma Boötes. Nope. Well, that's a bummer. Starry Night Pro. That's sad. We can't look them up by those Greek letters. It means we have to know some of the number designations. We're in H400 working. Okay, let's go back here and look at the live view again. Boy, that one star is very close to it, isn't it? 5557. Fifth magnitude Alpha Boötes. 54, or switch to chart 45B. 45B. Oh, that star that's beside it here doesn't even have a name in the Stephen James O'Meara chart. This is the Alpha star. That's the Alpha star. Maybe. Well, I'm going to stop trying to find the Greek letters because they're just more trouble than they're worth. Anyway, he says, under a dark sky, NGC 5557 is a very small, slightly condensed circular glow, and you only see that with averted vision. It's a swollen star-like core in a slightly oval halo. What do you think? Maybe the oval halo is caused by that glow of that nearby star. Larger telescopes may show a dim star immediately southeast of the nucleus. Yep. That's why it's an oval glow. So, thank you, Stephen James O'Meara. You're calling our 11-inch RASA a larger telescope because, and also with the help of EAA, you're calling it a larger telescope because you're talking about this very, very dim star. You know, you have to hand it to Sir William Herschel. By the way, he was knighted later on in his life in England. He was knighted Because who discovers 2,500 galaxies and nebulae? Who does that? Nobody else human. Only these big sky surveys. Okay, NGC 5557. I'm going to leave that open because we're kind of in that neighborhood. Let's do our log entry now. Let's see if we can open that back up. Yeah. This swollen star is actually an elliptical galaxy. So this brings up the question, what is an elliptical galaxy? I'll tell you a secret. I think astronomers use elliptical galaxy when they don't know how to describe it. I think it's basically a galaxy that's not a very clear spiral. That's what elliptical galaxy means. It's like oval, and they can't see much spiral structure. And that's it. So I think the word elliptical is a little bit overblown. It sounds so techy, but it really doesn't mean that much. An elliptical galaxy, we could easily make out the very faint star next door. Now let's go to Starry Night Pro Plus and get the real name of that star. Zoom, 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 zoom. Is it really that one? Apparently so. I'm not going to try to type that number, which had a very long USNO number. What does USNO stand for? U.S. Naval Observatory? What is that? Astronomy Catalogs, USNO. Yeah, it's United States Naval Observatory. They have a robotic astrometric telescope star catalog. Wow. Who knew? USNO number. I'm going to put in parentheses here. U.S. Naval Observatory. How did Herschel ever see this live? He did have an 18-inch telescope, but man, it was an old-fashioned one that he had hand ground. He had handmade the mirror on it. So, Sir William, hats off to you. All right, we're going to say this is 9 minutes on this thing, and rightfully so, because it's a pretty big deal. Now, we still got several people in the live stream. If you guys wanted to say where you're observing from, or maybe tell a little bit about your experience with the Herschel 400 list, we would love it, because this is the first time that we've tried to observe these objects. And I'm just going to be honest with you. This is new for us. These are brand new objects for us. All right, let's go to the next one. Let's do our little that was 50. $50, $55, $57. Yeah, it's checked here. So we're going to say, add that to the observed list. Now we're going to go back here to live sky. And can we just search for 55, 57, remove it, save it. Back to Starry Night Pro Plus. And let's do another sort. Now, what are the ones we've seen? Let's see. 5689. Did we do that one yet? NGC. We didn't. NGC. Now the next question is it west of the zenith? Can I tell by looking at this little? Can I tell by looking at this? Whether it's past, it's at 79 degrees, so it's not going to be that close to zenith anyway, is it? 5689, 80. Can we finish it? No matter where it is in the sky, let's do it. We'll just do it quickly. So we're going to slew, but first let's center on it. 5689, and let's also slew to it. So you see the scope stayed with the weights in the western sky. How do we know that? Because this camera is viewing the scope from the South Pole, so to speak. So the weights are on the west, the telescope is on the east. That means the telescope can continue to follow the objects into the west without the danger of running into the meridian like we did a while ago. See. Pretty fun, right? Learning all kinds of things. There's Stephen. I have zero observing experience. I'm a pre-beginner enjoying your live stream tonight. Stephen, we welcome you. So glad you're here from, I think you said, Arizona, didn't you? Scottsdale. You're in great skies, I bet. That's awesome. Jeff in Billings, Montana, haven't done the Herschel list. Jeff, you always amaze us when you come because I don't know if our rest of our studio audience knows, but whenever you come here, it usually means you spent the whole day in an operating suite. And I'm always sobered when you come because I always think, oh my goodness, you should be in some unused sort of like broom closet in some cot getting some rest before your next surgery. That's how I picture you. And instead you're here with us on this live stream. So thank you so very much. God bless you for doing this. Okay, anyway, we're here at NGC 5689. We should have slewed there, so let's go back to Starry Night Pro. Let's change our name up here to NGC 5689. And let's go down here to the title and say this is NGC 5689. And this is a spiral galaxy in Boötes. We're just hanging around in Boötes tonight, aren't we? A spiral galaxy in Boötes. Now this title text we just do that just for fun in case somebody looks at the YouTube and they're scrubbing across trying to look for a certain object. But the title target name we do in SharpCap, which is the observing program, that's so that when we start this imaging live stacking, it's good because when we save it later, it'll save it with that as the name. So that's why we have to put it in both places. We've never observed this target before. So let's add a log entry. Notice how our log entry, I don't know if you can tell, let me bring this over for a minute. Notice how in our log entry, it keeps the observing list that we're referencing. And we reference H400 all, and also keeps the session name. Now, does it keep the equipment? Yeah, it keeps the equipment that we're using. So it keeps all that. And we just, I'm going to say we could see this. Oh, this is this crazy thing that Starry Night Pro sometimes does. I've reported this to simulation curriculum and they claim that they're going to fix it. We could see this spiral from the first 20-second frame. One more time, it's done this funny thing where I know you're seeing this, you're saying, Doug, why do you want to use this software if it's got this glitch? We can see the spiral from the first 20-second subframe. I'll tell you why, because I love a lot of the other things so much that I'll put up with that glitch in order to be able to use everything else. Now, here's where I think we are. Oh, look, right there. That. But I was looking at another spiral here and another spiral down here. But let's assume that we want this one that's kind of in the middle. Now you see why I do like to plate solve first. You know what else we can do is go up into our tools. But I think first we have to plate solve only. So we're not resyncing. So we end up, doing a plate solve only anyway. And why am I doing this? I'm doing this because we're going to use the annotate. Jeff Horn, thanks, Doug. I will rest when I'm dead. You know what? I believe you. Because I know what they do to you guys in surgeries. They make you stay for double shifts sometimes because you're the only guy in town that'll cut open somebody else. Okay, now that we've plate solved, notice I didn't resync because that would have messed up our live stack. Now we can go to Deep Sky Image Annotation. And it'll tell us, yep, sure enough, that's NGC 5689. So what we did there is we let SharpCap annotate all these objects for us. And that way it sort of proves to us and the world that we're looking at the right object. So here we are at NGC 5689. Let's get rid of that annotation so it doesn't get in our way. Thank you, Robin Glover, for programming SharpCap so well. NGC 5689. I'm still going to leave my first sentence. We could see the spiral from the first 20-second subframe. It's a vertical spiral. Not quite edge on. You see how it's a little bit wider than edge on. Now let's see what Stephen James O'Meara says about it. I wonder if his 5689 is close by here. Nope, couldn't have been that easy. Maybe we should be using his list instead of Starry Night Pro looking for the highest object. 5689 is on 209, not very far away from where we were. A very small and dim galaxy. Think small fuzzy star. Well, now we could see there was a galaxy, Stephen James O'Meara. It looks like a puff of dim light. Once you get to a little bit larger scope, it displays a bright, fuzzy-like star-like core with dim extensions to the east and west. It's best seen with averted vision. This is H, Roman numeral 1-188. I forgot to write that down in the last one. H188. I'm going to say H space Roman numeral 188? Yeah, 188 on the Herschel list. Honestly, as O'Meara says, this object doesn't show off a lot of structure, but it's still very cool to revisit what Sir William saw in his, 19-inch scope. And when was that? Early 1800s, so 200 years ago. That's amazing, isn't it? All right, we're going to save this as seen. these targets are going to be so small in these big pictures that Starry Night Pro saves, because the, get a load of this, the, excuse me, I'm going to have to take a drink here. It's just water. This camera sensor is 6248 by 4176 pixels. So it's a huge sensor. It's APS-C on the 2600MC Pro. And this little tiny dot is going to be just that. Right in the middle of that frame, there's going to be this little tiny dot, like Stephen James O'Meara said, with these little extensions on it. All right, we're going to switch out of our sequence and click on our next target sequence. Now you can see what these sequences say. Stop live stacking, set exposure to 3 seconds, set the gain to 400, finish. I mean, you know, it's that simple. This thing is not rocket science. It just takes care of those 3 or 4 steps for us. If you're still using SharpCap and you're doing those things live, this just saves you about 4 clicks is all. Nevertheless, it saves you 4 clicks. All right, so let's take stock here. 5557 is what that was, right? 55, was it? $56.89. It was $56.89, yeah. $56.89. Let's double check that. Yeah, there's our observation we just made. Okay, so now we're going to say at 56.89, add that to the observed list. And then we're going to say over here in live sky, we're going to search for 56.89 and remove that, delete, and then save. Now, lest you wonder, does that really work? Let's just test it. Let's search for 56.89 again. And that's what it's doing in some kind of a weird world. And it's not finding it, you see? So it really does get rid of it in live sky. But this thing I showed you a while ago over here in Starry Night Pro does not get rid of it. I want to show you one other thing while we're here. I hope I don't get too distracted by showing you this here. I'm just going to make this a little bit wider and bring this over. Are you seeing this okay? Yeah. See this column that's blank? I don't know if you can make that out because it is a small, I bet small screen on your screen. In Starry Night Pro, there's a column here that's blank. Guess what that column is? The observed column. Starry Night Pro has a glitch in the observed column. Once they fix that glitch, when we observe this object, there'll be a check mark there. Why? Because we will have logged an observation right here. And what Starry Night Pro will look at is if there's an observation logged, it'll have it checked. So when you're going through the Herschel list for the first time, that column would be extremely convenient. I mean, it would be super handy. But I also said this to the people at SimCur. I actually don't care that much that that column's missing now because I've got this other workflow worked out. I'm adding it to this H400 observed list, which manually stacks it in there in this first time list that I'm making and that you're making with us. When I get ready to go through the Herschel list again someday, those are all going to look checked. And the observed column will be a waste of time for me anyway. Because once you do any observation, the observed column is going to be checked forever. So is it really that big a deal that that column is missing? I don't think so. But I will say this, the first time we go through it, it would be really handy and it would keep this little gyration that we do each time over at Live Sky. It would keep us from having to do that on the first time through. So there you go. All right, we're ready for the next object. Is it 5676 or did we already look at that? Let's show info. Nope, we haven't looked at 5676 yet. So we're going to put a check mark in the checkbox, and just visually, that helps me remember that we're doing this. But let's do center it, and when we center it, it'll show us, yeah, we're on the west side, right? How do I know that? Because now look, our scope is pointed toward Ursa Minor, the Little Dipper. And the fact that we can see those northerly constellations tells us that to the left of the meridian is west. So the sky has already rotated this object through the meridian, and we won't have a pure flip going on while we're live stacking. So let's indeed go to this object. And we can actually go to this object here, 5676, by saying slew to it. And the telescope didn't have to move very much, did it? That's a live view of the telescope you're seeing there. That's not a photograph. That's a live view. And this is a live view of the part of the sky you're seeing. That's fun. We can work on constellations. But we need to center it in our did we already center it? Yeah, I guess we are already centered. In our Planetarium software, we're already centered. So let's go back to, let's go now over to SharpCap. And let's change this name here, NGC 5676. I know what some of you are asking. You're saying, oh my goodness, he has too many things going on. There's just too much going on there. Well, let me tell you, astronomy is a personal hobby. This is a spiral galaxy, and it's in the constellation of Boötes. We're just hanging out at Boötes tonight, aren't we? So that's all correct, 5676. Back to the live screen. Let me just say, if you find that this is too much, too many things going on, too much of a circus. If this feels like too much of a circus for you, then here's my admonition. Just simplify it. Just pick out the things that you want to do. You might decide that you don't even want to use a go-to scope. You just want to be you and the Dobsonian. Or you might want to use a computer-guided go-to scope like a Celestron C8 or a C11 or whatever you have, C6. You might want to use your computer-guided scope, but you don't want to live stream. You might want to use the pointing program that comes with your telescope. And if that's the case, by all means do that, because I'm sure it's going to be easier than what we're doing in here. You might want to use ASI Air and not fool with SharpCap at all. See, that's the great part about astronomy, is that you get to decide those things. It's a personal hobby, and nobody's going to tell you how to do it. You get to pick your own way. Start imaging. I like this approach, and I'll confess to you, I'm now what, a year and a half into this, and I bet for the first 6 months I was forgetting to change these target names in SharpCap, and I've only been doing the title names for the last 6 months, so that was something I wasn't doing, so I've had to get used to doing that as well. So this is something that you get to decide. And part of this is due just because we're live streaming. You might think, oh my goodness, I am too embarrassed to do live streaming. You might feel that way. So then you don't have to. You don't have to live stream. Just do what feels good to you. That's the way you can look at this. Now you might notice when we zoom in too much, and like right now we're at 219%. what we've done is, first of all, we're zooming into the grain because we haven't live stacked. This is like 3 20-second images, subframes. And did you notice the grain just went down a lot with that third subframe? So part of what we're seeing is a grain, but the other part of this modelness, M-O-T-T-L-E, model nature, is the pixels, because we're zooming past the optical capabilities of our camera. And you guys that have used a 35mm camera, you might know there's like a optical zoom and then a digital zoom. And even on our cell phones now, remember, there is an optical zoom and a digital zoom. And the videos you watch on YouTube that teach you how to use your cell phone camera, they might tell you there's no use going past your optical zoom when you're taking a photograph that you're going to view later on your phone, because you can always gesture, enlarge the picture, and it's the same thing. The reason we do optical zoom enlarging in EAA sometimes, because you don't get to pinch this video and make it bigger, so to speak. So we do sometimes enlarge the object. And I think that with the nature of EAA, sometimes we can pick out structures. Now let's go back to 100%. This is 100%. And I'm sure on your YouTube screen, as you're viewing this, or whatever device you're using, oh my goodness, heaven forbid you're using a phone, because that'd be tiny. But if you're on an iPad or whatever, I'm sure that's a small object. So see, when I go ahead and zoom in with digital zoom, I think sometimes it does create a little bit more definition of the structures. And I'm kind of seeing a little bit of spiral structures here now. And that's cool. Let's look at this description. NGC 5676 is a spiral galaxy constellation Boötes located 110 million light years away. Now let me just digest that for a minute. 110 million years. 110 million years. Now, first of all, I want to confess, this is the apparent age of this object. Maybe when God created the universe, God might have created the universe 4,000 years ago. Well, if he did, he made this object look 109,996,000 light years away old, because this light that's coming to us looks like it's been coming for 110 million years. Now that's crazy. And as you watch this, if you're watching the live stream live, and thank you for those, I see several of you are. If you're watching the live stream live, you are seeing photons that are registering for the first time in 110 million years. Nothing stopped them. Think of that. There was never a planet in the way of this spiral galaxy, ever, until it hit our observatory right out there. And now I feel so guilty, because all the people that are in our shadow, not very many, they're not going to be able to see because we just blocked this set of photons from 110 million years ago, apparent age. But if God made the universe from scratch and he let it actually do a Big Bang and he let it play out like astronomers believe, then this object really is 110 million light years away. I don't even know how to get my arms around 110 million years ago this light started. And I don't know what was happening here on Earth when this light started. But that is a long time. Brothers and sisters, that is a long time. Let's see what Stephen James O'Meara said about this. NGC 5676. Oh, it's right here. It's a small, dim galaxy near 6 magnitude 24 Boötes. Barely visible even under a dark sky. Well, we're seeing it, Stephen James, but we're using EAA. He says it's a little more pronounced if you get up to 72 power. It's a dim oval glow. There's a very slight enhancement toward the galaxy's center. How about that? You know, I'm going to go a step farther. I think we're seeing, at least I believe I'm seeing, not only the core of this spiral galaxy, but at 5 minutes EAA, using a at least a RASA 11, we're seeing some spiral arms that are throwing out some material here. And that's when we've zoomed past our optical zoom. I know we're into digital zoom, but look at the way we can start to see some dust lanes. Right there is a very thick dust lane, ladies and gentlemen. We are here to tell you. And there's some material that's been thrown off. It's the end of an arm, I believe. Here is an arm, and there is an arm. And here is some froth. And there is some froth. Man, I'm looking forward to the James Webb Space Telescope, the JWST. Look at this galaxy, because tell you what, I'm going to move this right over here. I'm going to say, wow, after just 6 minutes of subframes, we could see the beginnings of dust lanes in this tiny, faint spiral galaxy. We could see spiral arm structure, though it was pixelized in our digital zoom. We could see gas and dust material being flung out from this galaxy. Amazing. See, EAA is amazing. Let's put down the Herschel number, H1-189. H, Roman numeral 1, which I use an I, 189. Now, I wish that once I put this in this text, I wish that SimCur could make it so we could search for that text, but it's not possible. Even though we put that in that text, it doesn't become searchable. We'll always need to know that it's NGC 5676. All right, let's save a copy of this. And we are in our last 10 minutes. We're going to switch to our next target sequence, which is the one that switches the gain up, remember? We're going to zoom back out to 100% to auto, which is like full sky. And we're going to go here to our, it was 5676, right? Yes. We're going to say add to the observed list 5676. Live sky 5676. Remove the save. And let's do another sort. Oh, look, the Spindle Galaxy. That's a good one to end on. Open up the info pane for that. Isn't that funny that that's in the Herschel list? We've done 4 observations of this before because I think it's also in the Caldwell list. Although I don't see a C there. Oh, it's a Messier object. What? Are you saying the Spindle Galaxy? NGC 5866? How can this be? Surely that's a mistake. NGC 5866. NGC 58. It is 213 H1215. 5866. It's a Messier object. It's in the constellation Draco. 5866. Well, that's just funny that Herschel chose some Messier objects for his Herschel list. Now, I have a theory This is just a theory. We can check this out afterward. What if, when Herschel did his list, what if astronomers hadn't added the last? Yeah, that's exactly what happened. Because look, it's M102. So remember, when Herschel did his list, there were only 100 Messier objects. It wasn't until the 60s that researchers discovered 10 more objects over a space of time in Messier's catalog that he had never published. So for his stead, they published the last 10 objects in the 1960s. Herschel didn't have the Spindle Galaxy in the Messier list as it was known back then. So he didn't know it was going to be on the Messier list. Messier, for his part, had looked at this, but he hadn't published it to the world. So Herschel saw this and thought, oh my goodness, Messier must have been drunk. Why didn't he see this? Now I'm looking here to see, has this already crossed the meridian? Just. So we're going to say salute to this baby. Right, there it is. You can see the scope. It's still staying Pier East. The weights are in the west. So the scope is still able to swing with the sky unimpeded by the meridian. We've got this open. It's M102, but we're not going to call it that. We're going to call it NGC 58, I guess. Or are we going to call it M102? You know we've got other pictures of this, so let's call it M102 so the pictures are side by side. So let's go to here in M102, and in our title, let's be a little more decisive. This is M102, this is, M102 parentheses NGC 5866 or H 1-215. H Roman numeral 1-215. A spiral galaxy in, where is this? Draco. That's right. We read that a while ago. Spiral galaxy in Draco. Spiral galaxy in Draco. All right. M102, we're ready to go here. I don't think, well, I can see it already right there in the middle. So I don't think we don't have to play solve. Let's just go straight to start imaging. And M102 is quite a cool object to make the Herschel 400. But that's a fun fact to think about, isn't it? That when Herschel observed in 18 whatever year he found this, I don't think Stephen James O'Meara tells the year that Herschel found this, at least not right here. He might say it in another part of the book. It's a moderately sized and highly condensed lenticular galaxy. See, they use this word lenticular and spiral interchangeably. Under a dark sky, it's just visible with binoculars with effort. If they're 7 by 50, you have to know where to look. It's a condensed elliptical glow oriented northwest to southeast with white wing-like extensions. It almost combines with a 11 magnitude star. The galaxy stands out much more brightly. Core is very small, very compact. It's nicely revealed, the spindle shape. The lens looks extremely uniform and smooth. Now, what does lens mean? A dust lane can be seen, a whisper of darkness that cleanly splits the central bulge. Now, that'll be interesting. Can we see this central bulge? Let's zoom in on this baby. Can we see the little racing stripe? Yes, look at that racing stripe. Bring this up a little bit. Wow, Stephen James O'Meara picked that out observing live. Now this is where I think it would challenge me. I don't think my eyes would be able to see that. Well, as we view these next subframes in the Spindle Galaxy, I just want to thank you again for being with us tonight on this live stream. We do these live streams in Emerald Hill Skies every clear night, up to 1 or 2 times a week. And if you like content like this, we would love it if you would subscribe. It's very easy. All you have to do is find on your YouTube panel there the word subscribed and click on it. You can also click a bell that's there if you want to be notified when we're doing a live stream and when there's new content. You can also click, if you like, but you don't have to, a thumbs up. That's your decision. If you like content like this, if you should decide that you do like it and you click the thumbs up, what it does is it does push it up higher in the searches that other people do. And if somebody's searching for the Herschel list and you click thumbs up, this will likely be in the top 10, even though YouTube has millions of new videos every day. This will be in the top 10. Why do I say that? Because I couldn't find another astronomer that had ever done this before. Used EAA to work through the Herschel list live. And you were here. You guys who are observing live with us were here the very first night that we did it. I want to say thanks to the people who observed live with us. We had like Papa Tech and Jeff Horn. We had Stephen Kaiser. We had Frank. You were there. And there were 5 or 6 others who never did quite identify themselves. And they were kind of hiding in the wings there. You guys, we appreciate the fact that you were here as well. Thank you for being with us. We'd like to invite you back, and we'll be working our way through the Herschel list, I am sure, for quite some time. We'll go back and pick up the stragglers that we still need to finish the Caldwell list, and I'm sure we'll be observing other things along the way too. We do little sky portraits of individual objects in shorter live streams. We hope you'll stop back and see those. Last of all, I want to say thanks to God for making these beautiful objects. This is now 4 minutes on this, and you can already see that beautiful little racing stripe that Stephen James O'Meara saw. I'm going to save an image of this before I forget, because I don't want to forget what God made for us. Thank you for being a part of this. God bless you. Have a great night. Have a great weekend. And we'll look forward to seeing you in the next one. God bless. Good night.